This video is going to demonstrate Experiment 6 in the Chem 1050 Lab Manual, Chemical Properties of Consumer Products. We're going to start with the procedure, Part 1, Analysis of Table Salt. So it says to take a small amount of table salt and put it in a test tube. So here's table salt. And using our spatula, we'll put some in this test tube. Next, it says to add approximately 20 drops of distilled water. So here's some deionized water, which is the same thing as distilled. 20 drops is about 1 milliliter. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 drops. We want to dissolve it. So I'll just put a little cap on this test tube, shake it up, and dissolve the table salt. So this analysis is to check for the presence of chloride ion in this solution. Get it all dissolved. Still a little cloudy. Those are mostly bubbles. Okay, so here's how it looks. Almost all of it's dissolved. There's a little cloudiness there, mostly due to the presence of bubbles. Or I might have added a little too much salt, so let's try a few more drops of the deionized water to make sure all the table salt's dissolved. So remember, when it dissolves, it dissociates into sodium ions and chloride ions, and this test is going to be determining for the presence of chloride ions. Okay, so the next part says to add 2 drops of silver nitrate. So silver nitrate will be providing silver ions and nitrate ions. So we're going to add just 2 drops. So watch carefully so you can write your observation. 1, 2. And you see the formation there. In part 2 of the analysis of table salt, we're going to be checking for the presence of sodium ion in the table salt. So the silver nitrate test is a test for chloride ion. We're going to do a flame test to test for the sodium ion. So first I will light a Bunsen burner. And there's your burner. There, you can see the nice blue inner cone, so it's nice and hot. Here's some table salt. And I'll put a little bit onto this spatula and hold it into the hottest part of the flame, which is the top of the inner blue cone. And you should see then that color, which is a kind of a yellowish, orangish color. That's typical of sodium. See how strongly colored that is? So the sodium atoms have a very strong transition with electrons that cause that color. So that's how we would do a flame test to confirm the presence of sodium ions. Moving on to the analysis of household ammonia. Ammonia is a base, chemical base, which is the opposite of being a chemical acid. Bases turn red litmus paper blue. So we're going to do a test on the ammonia to see if it is a base. So I'm going to count out 20 drops because that's a milliliter. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's my 20 drops of ammonia. And I'm going to put dry litmus paper into the mouth of this test tube. Be careful not to touch the sides. And I'm ammonia will evaporate into a gas and retain its properties, and it does so. Let me see. Well, you see what you see there, right? So put that observation down. Now I'm going to wet the litmus paper. I'll get a new one so it's completely unused. Red litmus paper. I'm going to moisten it with some distilled water. It's good if you take the cap off. So moist litmus paper, and now I'm going to hold it into the mouth of the test tube. The same way. And you see the effect that it had on the moist litmus paper. Now we've seen a test for ammonia. We're going to do a test for ammonium. So here is some ammonium chloride. Ammonium chloride, of course, contains NH4+, which is not the same as ammonia, but the test that we're going to do is related to the test that we just saw. So I'm going to take some ammonium chloride, small amount, and put it into a test tube. Then I'm going to add some sodium hydroxide. The sodium hydroxide base will convert the ammonium into ammonia, we hope. And then we're going to test to see if that is successful by doing the litmus paper test that we did earlier. So I'm going to wet this litmus paper with some deionized water, distilled water. Then I'm going to add the 10 drops of sodium hydroxide to our test tube containing the ammonium chloride. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. React a little bit, then put the litmus paper into the mouth and wait. See if it produces ammonia gas. And there's your litmus paper. So that's the test for, let's see, turn it just a little bit more blue. That's your test for ammonium ion. Reaction with sodium hydroxide produces ammonia gas, which then turns the red litmus paper blue. In this last part for the analysis of ammonium ions, we're going to be testing fertilizer for the presence of the ammonium ions. Fertilizers often contain nitrogen-containing compounds, and ammonium is a common component. Ammonium nitrate is a very commonly found fertilizer. So we're going to test this fertilizer for the presence of that ammonium ion, see if that's true. So I'm going to put a small amount into a test tube. Put this one here. And then I'm going to do exactly what I did with the ammonium chloride. I'm going to add 10 drops of sodium hydroxide and test it with some litmus paper that is moistened with some deionized water. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can encourage that to react a little bit, and then I'll put the litmus paper in the mouth of your test tube and wait. there you can see on the tip of it, starting to turn blue. We can try it for a little bit longer. Be careful not to touch the sides. It's not easy. There, that's a little bit more convincing. You can see that the reaction of sodium hydroxide with the ammonium ions has produced a substance that turned the red litmus blue, which indicates presence of a base. In this case, the ammonia gas is the base. Now we are moving on to the next part, analysis of baking soda. Baking soda's formula is sodium bicarbonate, NaHCO3. So we already know that there's a test for sodium ions, so we're not going to demonstrate that. Our test will be for the bicarbonate ion. So we will start by taking some baking soda. Let me find a clean test tube here. Ooh, I just cleaned one out earlier. Oh, there we go, clean test tube. We'll take the baking soda, and the instructions tell us to once again take a small amount. So there's a small amount of baking soda, adding it to a test tube. Now I'm going to be adding to this some water in order to dissolve it. It doesn't dissolve super well, but the instructions tell us to add 1 ml. That's 20 drops again, so we will do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20. Okay. I'm going to shake that up good to try and dissolve it as best I can. And it doesn't all have to be completely dissolved to see the effect of this analysis. So next we're going to add some sulfuric acid. It's 6 molar sulfuric acid, a little bit concentrated. And it tells us to add 5 drops. Oh, I'm sorry, I'm looking at the wrong part. Sorry. We're going to add 5 drops. Why question myself? So we're going to put 5 drops in here. And you're going to watch very closely and make an observation as I add the 5 drops. Okay, so that was fun. So that's an indication, the bubbles are an indication that we have carbonate ion or bicarbonate ion, either one. In this case, it's bicarbonate ion, and it produces a lot of bubbles when reacted with an acid. So we saw the reaction of sodium bicarbonate with an acid produces bubbles. So that's caused by the bicarbonate ion, so that's a test for bicarbonate or carbonate ions to see if they're present or not. Now we're going to confirm what we suspect the bubbles are composed of, and that's carbon dioxide. So if the reaction is what we suspect, we should be able to confirm that carbon dioxide forms. So the way we're going to do that is we're going to do the reaction again between the baking soda and the sulfuric acid. We will generate the bubbles, and then we're going to test the bubbles with some barium hydroxide solution. So the barium hydroxide solution will be placed on a wire loop. So see the little end, that loop on the little end? I'm going to put some on that tip. And then when the barium hydroxide encounters some carbon dioxide, the carbon dioxide, when it gets into the water, forms some carbonate ion. And the carbonate ion will react with the barium ion to produce solid barium carbonate. And we should see then the loop turn to a white color in the presence of the solid barium carbonate. So let's see how this is going to work. I'm going to go ahead and put a drop of the barium hydroxide onto the loop. All right. And then I will put some baking soda. I might have to do that again if the drop doesn't stay. Some baking soda into the test tube. Add some deionized water. A milliliter. Okay, and then I'm going to be ready with the sulfuric acid. Now I'm going to go ahead and place this loop right on top of here, so when the bubbles encounter it, hopefully you'll see it turning white. So here we go. 1, 2, 3, 4, 5. Here come the bubbles. And it is turning white in the presence of the carbon dioxide bubbles. If you look, see against my shirt, you can see now it went from clear to pretty much filled with that white color. That white color is barium carbonate, and that is an indicator of carbon dioxide bubbles. Now we'll proceed to the analysis of Epsom salt. Epsom salt is magnesium sulfate heptahydrate, that's how you call that, but we're going to focus on just the magnesium sulfate part. So magnesium sulfate contains magnesium ion and sulfate ion, neither of which we've analyzed for yet, so we're going to do each of those in turn. So the first test is going to be for magnesium. So I'm going to go ahead and start that test by adding some Epsom salt into a test tube. So here's my Epsom salt. Place it into the test tube. Then we're going to put in some water to dissolve it a bit. Milliliter again, or 20 drops. Okay. Now, in this reaction, in order to get the reaction to proceed properly, we have to add some sodium hydroxide. And you can look up the reaction in your book. But here's the sodium hydroxide. It says to add 5 drops. So let's do that. 1, 2, 3, 4, 5. Okay. So there's the sodium hydroxide. And then the magnesium in the right, you'll notice, forms this white solid in the presence of the sodium hydroxide. Now, to confirm that that's magnesium, this organic dye will turn it a distinctive color. So the dye is p-nitrobenzene azoresorcinol, and we're supposed to add 5 drops. So let's see what happens when we add the 5 drops. 1, 2, 3, 4, 5. Oh. So it started off kind of a orange color, but now you can see what color it is. And that's an indicator for the presence of magnesium ion, using the hydroxide and then the dye to show that magnesium is present. Now we're going to test the Epsom salt for the presence of sulfate ions. That's what our next test is going to do. We'll start with our Epsom salt, and we're going to add to that some barium chloride. Barium forms an insoluble compound with sulfate. So magnesium sulfate is soluble, but barium sulfate is not. So let's go see how that's going to proceed. So we will add our typical small amount of Epsom salt, then the deionized water to dissolve it up, now I want to dissolve this up a little better than the last one so that you can see for sure that we're making a solid only when we add the barium chloride. It's a little bit stubborn. Pretty well. There's little crystals down at the bottom. I'm going to add a little bit more water to it to get it to dissolve up a little bit better for us. Okay, that's pretty good, right? Nothing there. Okay, so let's add the barium chloride and observe what happens. So it's telling us to just add 2 drops. So just little 2 drops. Let's see. immediately you can see, that's kind of pretty, except it's white, but other than that, it's kind of neat. Like it falls down like snow, that's why they call it a precipitate. So indeed, that shows us that we have the presence of the sulfate ion because it forms a solid in the presence of barium ions. So now we're going to do an analysis of bleach. Bleach consists of sodium hypochlorite, so sodium ions and hypochlorite ions, which are listed, they're written OCl in the lab, but you can write them also ClO negative, are dissolved in water to make bleach. The sodium ion, we've already seen a test for that. That's a flame test. So this test is going to demonstrate a test for the hypochlorite ion. Now this is going to be a little bit more complicated because what we're going to do is a reaction where the hypochlorite ion reacts as if it is Cl2, even though it's not. It is a test for hypochlorite ion, not chlorine gas, but it is going to do a similar reaction that you see in your book. And it's going to react with iodide ions to produce iodine, I2. And then we're going to show how we can visualize the I2 at the end of the reaction. So let's start. We have to add in some potassium iodide. That's going to be the source of our iodine. So here's potassium iodide. And we'll put a small amount into a test tube, just like we've been doing. And then it says to add some deionized water again. So here's some deionized water, and we're going to put in 20 milliliters, pretty much like we've been doing. So 1, 2, 3. So 20 drops, that's our 1 milliliter. I'm going to dissolve it up. Shake, 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 shake. Yeah, that's pretty dissolved, right? That's pretty good. All right, now next, it's a little bit tricky. We're going to add our bleach. So it says to add 1 milliliter of bleach, so that's 20 drops. And then we're going to add hexane. Hexane is an organic solvent that does not mix with water. It is less dense than water, so it's going to float on top. And what happens is we're going to form iodine, I2, from the I negative. And the I2 is dark colored, and we should see it then in that upper level hexane layer because it's more soluble in the hexane than it is in water. All right, so here we go. The bleach first, and we need to add 1 milliliter. Now remember, this is an analysis of bleach, not the Ki. The Ki is used to react with the bleach. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the reaction's actually occurring between the hypochlorite ion and the I negative producing iodine. We're going to try and visualize it by adding this hexane. So we have to add 10 drops, a half a ml. Now what we want to do is get all the I2 that's forming into the hexane. So we're going to shake it up. This is called an extraction. So that the hexane can mix with the water as well as it can, but it won't stay in the water because they do not mix well. The hexane is nonpolar and the water is polar, so they don't like each other. So over time, it's going to separate. So we'll have to let it sit there, and then we're going to take a look at it after some time has elapsed. And if we do that, if we let some time elapse, this is like a baking show now. I'll just pull this out of the oven. And you can see that top layer, see how it's a little bit purple? That's the I2 that we extracted out. The I2 is there because it reacted with the hypochlorite ion, so that is a test for the presence of the hypochlorite ion. A little tricky test there, but in the end it works. Let me see if I can put a little bit of white paper behind that so you can see the see that? See how it's a little purplish? So that's the I2 that's in the hexane. So in this last part of the experiment, we're going to be testing for the presence of phosphate ion. We're going to be testing 3 different substances. One definitely has phosphate in it. It has sodium phosphate. And then 2 commercial substances, detergent. Many detergents contain phosphates. And fertilizer, the fertilizer we tested before, we tested positive for ammonium ion. Now we're going to determine if this is ammonium phosphate fertilizer, as many fertilizers are. So I've already put in some sodium phosphate in test tube 1, some detergent in test tube 2, and some fertilizer in test tube 3. Now I have to dissolve them in water. I'm going to add a little bit of water. It says to add 2 mils. So I can eyeball that out. There's some water in there, and then some water with our detergent. And then some water in our fertilizer. I want to shake these up so that they dissolve as well as possible. The sodium phosphate is already in a water solution, so I don't shake that up, but I'll shake up the detergent. See how it's getting all bubbly because it's detergent. And then the fertilizer. Probably won't all dissolve. There's some insoluble substances in the fertilizer, I think. We will see. I'm not going to worry too much if there's a little bit undissolved. Okay. Now, in order to activate the reagent that's going to test for phosphate, which is this molybdate reagent, I'm going to add some nitric acid. The nitric acid will activate and make the molybdate substance react properly with the phosphates. So I have to add the nitric acid into the test tubes until they test acidic using litmus paper. So when we test for bases, we test to see red litmus paper turn blue. We did that already. Now we're testing for acidic, so we're going to take blue litmus paper and make it turn red. So testing before I add any nitric. This is the phosphate. I touch some of the solution. Do this side of it a little bit better. And I see that the paper's not changing color, so I add a few drops of nitric acid. Stir it and see if it turns acidic. Nope, I got to be a little bit more aggressive. Add a few more drops of nitric. It needs to be acidic. Nope, more aggressive even than that. Okay, we'll keep going here. More nitric. Stir it up. And just getting there. See how it's turning just mildly red? I'm going to add one more drop and see what happens. We'll turn it over to the other end. Oh, I'll get a fresh one because that one's getting a little acid from the nitric on it. It's making it turn red. I don't want to do that. I want to make sure it's the solution I'm testing. Ah, there. See? Now it's turned red, so that's enough nitric for that one. So let's do the same with the detergent and the fertilizer. So I'll do an initial quick test of the detergent, and I'm not expecting it to be acidic because I haven't added any nitric yet. And no, not yet. So I'll add, it seemed like it took a lot of drops for the sodium phosphate, so let's see. I'm just going to add just 5 to start and see what that does to my detergent. And oh, that was plenty. It's turned just mildly acidic, just a little bit red, so I'm not going to add any more. That looks good to me. Then the last one, the fertilizer. So the fertilizer I'm expecting will not be acidic until I add the nitric acid. So I'll test it. Oh, it is testing acidic. It might be an anomaly. Maybe I didn't get all the nitric rinsed off my testing rod. Let's try that again. It could be acidic because there is ammonium in it, and ammonium, unlike ammonia, is an acid. So indeed, it's already acidic, so I'm not going to add any nitric acid to it. All right, so then I'm going to, according to my instructions, I'm going to add the test reagent, but it also needs to be heated in order to activate the reaction. So before I add the molybdate, I'm going to put them in a boiling water bath. So this is not boiling. So let's get it boiling, and we'll put it in here, and we'll wait for it to boil, and then it has to boil for a few minutes. So let's let it boil. Okay, so after it's been boiling for a few minutes, we're going to remove the test tubes, and we're going to add in the molybdate reagent and then put it back in the bath. So I'm going to go ahead and do that. I'm going to move this rack here so you can see that. I'll just see. Hopefully it's not too hot. Ouch, ouch. Hopefully it's me doing this and not you. Ow! Don't have my test tube rack. It's okay, I'm alright, don't worry about me. Okay, so there's the test tubes. They're not in order. This is 1, here's 2, and here's 3. So you notice that the fertilizers always have kind of this yellowish color. So here's the molybdate reagent, and we're going to add, it says to add something, 15 drops. So let me open it, and we will add 15 drops. I'll hold it up so you can see it. So the molybdate you see is already kind of yellowish. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 15 to this guy. And 15 to the last one. You see how deep gold in this last one. Remember that this is test tube 2. Actually, it's our detergent. This is our number 1, which is our sodium phosphate, and then of course this is the fertilizer. So we return it back and reheat for a few more minutes just to make sure everything's complete. And this reaction should produce a yellow precipitate. So we're looking for it to hopefully turn a bit cloudy for us so that we see that some solid is formed. This thing's a little bit dicey sometimes. Hopefully it's going to work for us today. Okay, so in test tube 1, which is the one that contained our sodium phosphate, you can definitely see a precipitate is formed on the bottom. See how it's solid? It used to be completely clear. So the bottom now has a little bit of precipitate. So it definitely succeeded in our sodium phosphate, which of course we would expect because we knew it was sodium phosphate. Ouch. I don't see anything in the, I mean it's yellow, but I don't see a solid like I did in the sodium phosphate forming with the detergent, or this isn't detergent. Oh yeah, it's a detergent, I'm sorry. I don't see it forming in the detergent yet. So I don't have any test tube holders, so I'm burning myself. Ow! And I don't, oh, you know what? I do see in the fertilizer. Yeah. I think on the sides, if you see a little bit deposit on the side there, it's cloudy. And that's not on the outside, that's on the inside. So there's a little bit of precipitate on the side in this fertilizer. And we'll give it a couple more minutes for the detergent to see if that's going to come around and form a precipitate for us. But this reaction can be a little bit stubborn. It's okay if we don't see it. That would just lead us to the conclusion that there was not phosphate in this particular detergent, or at least not enough for us to detect with this particular test. I'm going to take them out out of the rack and see if by cooling it, I can encourage the precipitate to form a bit. Ouch! Never mind me. Oh my gosh. I know you're probably laughing at me right now. Let me just take it down a bit. Let's see if I can get it out. Out. Scorching my fingers. Wowzer. Do not do this at home. Okay, I'm going to cool that down and see if that'll encourage our precipitates to form. So I'm going to put a little cold water into our beaker. Let's see if maybe it's just a little too, now, ooh, okay, so here, now number one, like I said, for sure has precipitate in it. You can see that it's cloudy. I'm going to put it in there and see if that encourages more precipitate. I don't see anything in the detergent one yet. I'll see if maybe some form if I cool it down a bit. But I do see some in the fertilizer, definitely. If you see at the bottom, for sure I'm getting some cloudy precipitate down there with the fertilizer. So it's only the detergent right now that I can't see phosphate with. And it may be that this detergent doesn't have phosphate, and that's okay. We don't have to have a positive test, but I'm going to give it every opportunity to turn into a positive test. And it does not look like I'm going to get one today, folks. So it is possible that this detergent did not have phosphate in it, but definitely we see it in the fertilizer where we see that cloudiness in there. That's precipitate. And then, of course, we expected to see it in the sodium phosphate because we purposely added it into the sodium phosphate.